Hi, so in this model, we are going to look at the way that we can actually calculate maximum sustainable yields and the fishing effort that leads to this maximum sustainable yield using only capture per unit effort data. And we're going to use the data set that was used in those graphs. And I'm going to go through these calculations for the Sheffer model, and then I will leave it to you to replicate these calculations for the Sheffer model, and then do the same calculations for the Fox model. The idea is basically the same. So let me share the screen now, this screen, and you have access to this data set from the presentation I just showed you, and there will also be a link to it in Moodle. And I'm going to go through this with you right now. So basically what you have is the yield from a given fishery in 1,000 tons, and for the same year the corresponding effort. In this case, the effort was done as a number of standard boats, because of course in this area there were different kinds of fish, some smaller fishing boats, some smaller, some larger. And so what they did was they translated, they standardized the fishing effort to a particular kind of boat, right? So say, imagine if this was had to do with the size of the boats, then a 10-meter boat would be equal to 2 5-meter boats. And that's what they did here. We don't need to worry about the details. Sorry. This was not necessary. So this is our data set, right? And what I'm going to do with you is going through the steps to calculate the fishing effort that leads to maximum sustainable yield using the Sheffer model. So a good practice is don't change the data sheet, right? So I'm going to create a new sheet and I'm going to call it Sheffer because that's the model I'm going to use. And I'm coming here and I'm going to copy the data that I need. I only need yield and fishing effort. So I'm going to copy this and put it here, right? And now if you remember, and I'm going to show you the presentation, if you remember, the Sheffer model assumes that there is a direct connection, a straight line connection between fishing effort and capture per unit effort, right? So we need to calculate the capture per unit effort to be able to make these calculations and then estimate the parameters from the Sheffer model. So let me go back to our calculation. So I need to calculate the capture per unit effort. And of course, capture per unit effort is the yield, and this is represented by this Y in a given year, divided by the effort, fishing effort, represented by F in this same year. So the formula is very simple, it's just yield divided by effort, right? There you go. Let's have a look at this. We've seen this graph already in the presentation, this should be no surprise. So let's just have a graph. And there you go. A bit big, let me put it a little small, and there you go. So again, this decreasing series where higher fishing effort translates into lower capture per unit effort. Let me just give you a note here. To be able to use this model, you need this kind of data. So you do not need just a set of effort and captures. You also need this set to cover a wide range of fishing efforts and a wide range of capture per unit efforts, so that you'll be able to have this nice series to adjust your model. Now, the model adjustment can be done mathematically, but There is also a way of doing it directly in these spreadsheets, and in this case, you can do it here. So you just add a tendency line, and in this case, a linear relationship if you're using well, Excel or anything else. And of course, you can show the equation. There it is. And you can also show the R square. R square gives a measure of how good the adjustment is of the data to your line. And there you go. Right. So now we have the line that translates the Sheffer model. Right. And you have the parameters A and B. So the parameter A is this value here, 0.106. Oh, sorry. That's not what I wanted to do. I wanted to put 0.106 here. Okay, and we also have B. And B is the slope of the line, and it's represented by minus 0.1234 zeros 429. There you go. There's your A, there's your B. I'm going to give these cells names, right? So I'm going to click here, and I'm going to go to this corner where you have J4, and I'm going to replace J4 with the name of the variable. In this case, it will not accept just A, so I'm going to call it A underscore, right? And now this cell is called A, and this cell is going to be called B. Again, B underscore, right? So we have everything we need, right? Now we can calculate from just these two values, we can calculate the maximum sustainable yield. We can calculate the fishing effort. We can calculate the fishing effort that will lead to the maximum sustainable yield. And we do this using the equations that have been presented and that I don't have in my head, but which I will go, if this thing will help me. There you go. I'll look them up here in the presentation, right? So this is the equation of the Sheffer's model. And from this, you can calculate, as I said, the maximum sustainable yield. So the F that will maximize the Y, and using these two formulas. So for the maximum sustainable yield, you just have to multiply minus 0.25 by the square of A divided by B. So let's see if I can remember this long enough to write the formula here. Sorry. No, that's easier. Okay, here we go. So this would be equal minus 25 times A, and I'm going to write the A underscore, right, so that we know what we're talking about. A squared divided by B. And of course, there's a problem here because I know what the value is, and it's supposed to be 60 something, not 6,000 something, and that's obviously because I've made a mistake in the formula, and the formula is not minus 25, it's minus 0.25, right? So there you go. The maximum sustainable yield is 65.5 thousand tons. How many boats, how many standard boats need to be operating to get this sketch, right? And you can calculate this using this other formula here, which is minus 0.5 multiplied by A divided by B. So that's what we're going to do. So 0.5 times A underscore divided by B underscore. And that's minus 0.5, of course. And there you go. So you need these amounts of fishing effort, in this case, number of standard boats, to be able to get that maximum sustainable yield, right? And so these are your targets. So you go to the politicians and you tell them, this is how many standard boats you need to have operating, and this is what you would expect to have on a sustainable basis. Let's, in any case, and just to complete this analysis, let's have a look at the shape of the model, because we're not looking at the model yet. So we've just calculated the parameters and calculated the values we wanted. We haven't looked at the model. So let's do that. So in this model, what you have is a relationship between fishing and captures, right? And you have the equation of the model here. So the yield equals A times the fishing effort plus B times the fishing effort squared. So that's our formula. Let me see if I can copy it and paste it here so that I don't forget it. Here we go. So for the Sheffer model, the Sheffer model will give me Y yield based on the fishing effort there, right? So I'm going to use a set of fishing efforts. I will start with 100 and go until 2,500. That's a bit more. Very good. Of course, I already know these are the numbers I would expect. You would probably have to experiment with this. But anyway, so you give, to look at the model, you give it a range of X values, and then you calculate the Y values using this formula. So it would be A underscore again times the fishing effort, and you add that to B times, sorry, A times the fishing effort, and you add, yes, B times fishing effort squared. Okay. There you go. So now you have the relationship between fishing and yield. And just by looking at the numbers, you will see that it increases as fishing effort increases, captures increase until a certain point, captures start decreasing again, right? And so if we do a graph with these values, where is that? You will get a representation of Sheffer's model, right? So, and I'm going to put it up here in the sequence. Right. There you go. So this is where you see that there's a maximum yield related to a certain value of fishing effort, and that's where that's where the conclusions come from. So you can, using this model, you can say, well, if you don't use, how many were there? if you don't use 1200 boats, right? If you use 1000 boats, then you'll get a smaller catch, presumably, if this model is working. And if you double the fishing effort, from 1000 boats to 2000 boats, you will in fact decrease the captures, right? So it's not profitable. That's how this model is supposed to work. So you should now do the same. You should now try to read these calculations and also do them from the start for the Fox model. There is a small detail in that the Fox model requires that before you do you calculate the tendency line, you need to calculate the logarithms of both the fishing effort and the yield, because the Fox model is not a linear model, is a logarithmic model. But other than that, the calculations are the same. Good luck.